Welcome to Tech for Novice, your channel dedicated to technology for beginners. Some hardware upgrades are easy. Computers slow down with age, which can be reversed. Today we are going to explore how simple hardware upgrades could provide a new lease of life for underperforming computers. PC may require additional drive space if free space is limited. File transfer and applications loading is very slow and disk activity is too frequent. If the PC has no faulty components but has performance issues such as slow startup and shutdown times, restarts unexpectedly, freezes or crashes frequently, applications close on their own and decreased overall system responsiveness, then it is time to consider hardware upgrade. A PC basically consists of input devices such as keyboard, mouse, camera, scanner, processing unit with CPU, GPU, RAM, HDD or SSD for storage, and output devices such as display and printer. A small program stored in motherboard called BIOS or Basic Input-Output System starts when a PC is switched on. UEFI or Unified Extensible Firmware Interface is advanced version of BIOS. UEFI can access full hardware while BIOS can't control even a mouse. BIOS identifies, tests, and initializes connected hardware components such as keyboard, RAM, and hard disk during power-on self-test or post. Then Boot Manager passes the control to bootloader of one of the installed multiple operating systems. Bootloader loads operating system or OS from hard drive into system memory or RAM. Finally, OS takes control and presents login screen after initialization is complete. Operating system is software bridge between user and the computer's hardware. It manages hardware resources like CPU, memory, storage, and input-output devices and application programs using these resources. Operating system, software programs, and other data are loaded to RAM for quick access by CPU. High speed is the RAM advantage over other storage devices. CPU fetches necessary data from RAM and stores in CPU registers for processing during program execution. Data is continuously moved between RAM and CPU registers as required. RAM is relatively expensive and power-hungry component of a PC. RAM capacity installed in a PC is limited due to cost, form factor, and motherboard support. Usable RAM capacity may be lower than installed capacity due to OS limit and reservation for display card. Operating system kernel is loaded from HDD into RAM and stays there until shutdown. Other components are loaded and unloaded depending on demand to maximize the use of limited RAM capacity. Large programs also load basic components into RAM at startup, and additional features are loaded only when required. Applications load quickly. Multitasking is seamless and no noticeable slowdowns if RAM is enough to handle current tasks. Windows takes longer time to start with increased number of installed programs as many programs add themselves to the list of startup programs. They slow down boot-up time and fill RAM space. PC will start using part of HDD or SSD as virtual memory if RAM is not enough for current tasks. RAM data currently not in use is transferred to hard disk to provide space for other programs and data in RAM. When the data transferred to hard disk is needed again, it is transferred back to RAM after moving data not in use to hard disk. Virtual memory is a section of HDD or SSD used as RAM to expand memory capacity. While this allows to run more applications than physical RAM would normally allow, it comes at a significant performance cost due to significantly slow data transfer between hard disk and RAM. Due to insufficient space to load entire programs, only basic components of them are loaded from HDD to RAM for fast access by CPU during execution. Only a small section of a program called process can run at an instance. A running program could have one or more processes in memory at the same time. Processes and data not in current use are offloaded to virtual memory to make space available for other processes and data currently needed. Processes and data may need to be moved between RAM and HDD frequently, which will slow down the operation significantly. Performance can be improved with reduced use of this bottleneck by increasing RAM capacity, increasing virtual memory speed with faster disk drive, running fewer applications and fewer or no memory-intensive programs. With more RAM, more data will be available for quick access by the CPU and reduced data transfer to and from slower storage devices. Overall result is faster operation. Avoiding virtual memory completely is impossible due to limited RAM capacity installed in a PC. Therefore, virtual memory speed is crucial for performance, regardless of RAM capacity. Replacing HDD, especially a boot drive, with a SSD improves performance significantly as programs will load faster and virtual memory will be more efficient. We have two bottlenecks related to memory. One is physical RAM capacity and another is virtual memory or disk drive speed. Both of them are relatively simple to solve. Usually, higher speed RAM is out of question for an old system to do system bus limitation unless major upgrade with new motherboard is under consideration. If PC has extra room for a new drive, then either HDD or SSD can be added. Higher capacity HDD could be more cost-effective for long-term data storage as lower performance should not be a big issue. However, SSD could be better option for frequent transfer of large volume of data. Replacing existing HDD with a SSD will improve performance significantly, especially if it is a boot drive. As SSD is very compact, desktop PCs should have room for one or more SATA SSDs. In general, SSD could be better option in most situations if no cost issue. Slow HDD drags PC performance due to longer loading time for programs and data, and slow virtual memory will add CPU waiting time to access necessary data. SSD should be first choice for replacing HDD for performance boost. SSD with DRAM or dynamic RAM cache is better for a boot drive, but performance boost will be significant even without DRAM cache. If the bottleneck isn't RAM and system still has an HDD, then replacing it with an SSD should be first priority. Checking current RAM usage can help to decide if additional RAM capacity is necessary. Start Task Manager with pressing Ctrl, Shift, and Escape keys simultaneously. Select Performance tab and then Memory for usage details. When experiencing a slowdown, check in use and available sections. If available RAM is low during each slowdown, then more RAM could improve performance. If you decide to upgrade RAM, then compatibility should be checked carefully before purchasing new RAM. Each motherboard supports only one generation of RAM, like DDR3 or DDR4 or DDR5. DDR3 is the supported RAM generation in this example. Another criterion is clock speed, 1333 MHz in this example. Speeds of RAM modules can be mismatched at the cost of higher speed RAM modules running at the speed of slowest module. Mixing RAM modules with different speeds could create stability issues in some rare cases. RAM modules faster than system bus will run at bus speed and therefore no performance gain with extra speed. All of 4 RAM slots are used in this example. Replacement with higher capacity RAM could be an option if motherboard supports more capacity. DIMM is RAM module form factor usually found in desktop computers, while SODIMM is form factor used in laptops. In case of mismatched cache latency, system will use higher cache latency. You can check existing RAM modules or PC specifications to find out if error-correcting code or ECC RAM is required. Consumer PCs almost certainly use non-ECC RAM. Memory requirement depends on how the PC is used. 8 GB of RAM could be sufficient for casual use, while at least 16 GB is recommended for running multiple demanding apps. 32 GB or more is required for professional works, heavy multitasking, and media-rich tasks. If the system doesn't use all of available RAM on a regular basis, then adding more RAM will have no noticeable impact. Another easy upgrade is graphics card, which can enhance display performance such as display resolutions and refresh rates. Laptop graphics cards are usually soldered on motherboard and therefore not easy to replace. Usually, it might not be worth upgrading old PCs with graphics card. While upgrading CPU is possible, but it may not be cost-effective for older PCs unless compatible CPU is available at very low price. Many laptop CPUs are soldered on motherboard and therefore no need to consider for replacement. Thank you so much for watching. If you like this video, please comment, share, thumbs up, subscribe, and press the bell icon.